All right, so let's begin then. So, good morning, everyone. My name is James Mota, and I am an AWS certified cloud practitioner. So, I would like to present a project that I've been working on for a couple of months now, which is on managed authentication. So, maybe before I continue, can I know how many have worked with any kind of authentication, JWTs, anything? Yeah, all right, okay, that's good. So, so let me quickly jump into what it is that I am trying to do here. So you see, when it comes to manual authentication, there are a lot of risks that come with it. So of course, for most of our projects, we are forced to deal with manual authentication, but question arises, what is this managed authentication, where you offload certain parts of your authentication to a third party provider maybe. So what this demo aims to prove is to show you how managed authentication can make your development a lot easier. So there are three phases in this demonstration. So first we have the general web security basics. I'll just go through a couple of topics just to maybe get you up to speed on the security practices and security methodologies as well. And after that, we have the second phase, which is Spring Security. And finally, we have Cognito. So I will show you just how cumbersome and difficult it could be when you are to make your own authentication, when you are to make manual authentication using what is probably a robust backend, which has you catching every single exception that there is, Spring Boot. And finally, we'll get into Cognito. So the stack for this project, for manual authentication, we have Spring Boot. And for Cognito, we have React, Spring Boot, and AWS Cognito itself. So right before I get into my presentation, a few rules. So this demo is recorded live. So if you have any questions, I'm sure you all have the slides. So if you could mark down slide number alongside your question, I will answer it right after the demonstration. And yes, so again, this is not a lecture, it's a demonstration. So I won't be going too deep into certain concepts for the sake of time. So just remind you again that this is a demonstration. So let's jump into general web security. So we have certain content which I would like to go through with you. We have OWASP, we have CSRF, COS, stateless versus stateful, and OAuth 2.0 standard. So let's quickly go through all of these concepts for the sake of time. So OWASP, anybody heard of OWASP? Maybe you might have gone. Yeah. So OWASP stands for the Open Worldwide Application Security Project. So to put it very simply, to summarize it into maybe one sentence, OWASP gives you a kind of list of security vulnerabilities from every year. It analyzes reports, security outages and such, and it kind of makes it into a list for each year, showing, okay, look here, for 2025, these were the security vulnerabilities, and it condenses all of that down into one list. So as of 2025, you can see there are these are the top 10 vulnerabilities. So if you have a look at point number 1 and point number 7, which is broken access control and authentication failures. So most of the time, these issues actually arise because of manual authentication, actually. Because you see, manual authentication, yes, there is a lot of programming. But alongside that, you also get the liability of security. I'll explain more on this later. So this is just to show you how, this is just to show you what happens when manual authentication when it just to show you how manual authentication can fail sometimes. Let's move on. So CSRF, cross-site request forgery. So what happens in CSRF is, so I'll just maybe take a very quick example just to show you what it's like. In CSRF, now I just want you to imagine you're in your browser, all right, and you have two tabs open. You have a tab which is, say, to a bank site, and you have another tab which is from a uh, which is to a malicious site, all right. So in the bank, so let's say you have logged into the bank site, all right, and they issue you a session cookie, all right. So it's stateful. So now this session cookie is stored in your browser storage, and whenever you make requests to the bank, the browser invisibly, of course not necessarily knowing to you, it fires that cookie alongside with it to prove your identity, right? So now, to be very honest with you, CSRF is it's a bit of an old vulnerability. We don't really deal with that much right now because we have got into stateless. But just for the sake of this demonstration, I would like to just let you know about what that is exactly. So basically, because the browser sends this session cookie invisibly, this can actually be exploited by hackers. So remember I told you that there was another site. You have the bank site, and so let's say you've logged into the bank site, you're sending requests, and you have this other tab as well, which is this malicious site. So now just think, in this malicious site, there is an image tag like that, IMJSRC, and that very suspicious link. So you see, when that image actually loads on this hacker's site, let's call it hacker's site, when it loads on this hacker's site, and so this request will actually be fired alongside that session cookie that you have from visiting the bank. So that is pretty much what CSRF is condensed. So we won't necessarily be working, we will be working with CSRF, but this is mainly a stateful related problem. I'll get to what I mean later. And then we have COS. Anyone here tried to connect your front end to your back end? You probably would have seen this error, right? Maybe your console is flashing red, contrast origin. So COS is actually, it can be divided into two, right? So we have simple requests and we have pre-flight requests. So maybe you might have worked with simple requests, maybe your standard GET requests, your POST requests to your backend. And so this is actually, it's quite easy to configure. All you have to do is just whitelist that origin, whitelist your front end in your backend. So simple requests are, well, it's simple to configure, right? So, and then we have maybe something which you might not really know about, which is pre-flight requests. So you see, if you were to attach some kind of header, let's say authorization, right, and you are sending that to your backend, so we call this pre-flight requests. So these, so the header that you are sending, it will have to be accepted by your backend, right? So in order for that to happen, your browser will actually kind of fire an invisible HTTP method called options, right? So to put it very simply, it's like a schema, right? So just think you have the front end and the back end. So the front end is asking the back end, okay, look here, I am sending you these headers. I'm sending you this authorization header. Is that okay? So your backend should say something like, okay, I trust this header that you are sending me. It can be allowed, right? So to put pre-flight requests in a very simple way, that is what that is. So we'll be working with pre-flight requests very soon. Yeah, so let's continue. Right. Now comes stateful versus stateless. Remember that example that I spoke about earlier, CSRF, where we had these session cookies issued. So these are actually stateful, right? Your server, or yeah, let's say your backend has the responsibility of basically kind of remembering who the person is, right, when you send these session cookies. So of course, now I just want you to assume that your backend, let's say something happens and it has to restart. Then what's going to happen? All of your users are going to get logged out because it keeps track of state of the user in its memory, right? And then we have stateless, which is JWTs, JSON Web Tokens, which can be quite interesting to work with. So in stateless, the JWT itself proves its validity, right? We'll have a look at the structure of JWT later so you can really understand what it is I'm talking about. But basically, the token itself that you are sending alongside that authorization header, that is what proves its own validity, and that is what proves who the actual user is. So that is stateful versus stateless. And then let's have a look at what OAuth 2.0 is. So OAuth 2.0, there is quite a lot of documentation surrounding this, so I'll try to condense it as much as I can. So I want you to assume that you are logging into Airbnb, all right, and let's say you have forgotten your password. Happens, right? So when you forget your password, what do? You sign in with Google, right? So to explain what is actually going on here, so when you give access to when you give access to Airbnb to get your password from Google, you are trusting it with that, right? So okay, maybe I'll try to explain the entire flow here. So let's think you want to log into Airbnb and you want maybe some data from Google, right? Because you're trying to sign in with Google. So Airbnb will have to talk to Google, right? So Airbnb asks Google, okay, look here, your user is trying to log in. Is it all right if I could have their data, right? And then Google doesn't just give the data, right? It has to ask you, is that all? Is it okay for Airbnb to access your data? And that's what it does. So Google asks you, okay, look here, Airbnb is trying to access your data. Is that all right? And you consent to it. You say, yes, please do. And then after that, Google gives your user data to Airbnb, right? And afterwards, you are able to successfully log in. So to put OAuth 2.0 in a very kind of condensed way, this is what it is. And this is third party delegation. Actually, we'll be having a look at what first party is when we get into the Cognito. Yes. Yeah, so that was just a quick touch up on some general web security practices. So now let's quickly jump into Spring Security after a 2-minute break. All right, so let's continue. So we are actually diving into probably a very, I would like to call it as a black box kind of mechanism, because there is simply so much going on with Spring Security. It would probably take me an entire lifetime to understand how it is that these are configured. So I'll just quickly maybe take you through the process of it. Maybe I wouldn't necessarily go too deep into explaining what is going on, because like I mentioned, there is so much of black box happening. So yeah, let's get into Spring Security. So remember here, this is the manual authentication flow, right? User signs up, we send an email asking them to we send an email asking with an OTP, they have to enter it, and then after that they are verified, they get their JWT, right? So it's quite a, we are making it a bit simple here, but although I know I said all of that, it might seem like a very simple flow, but when it comes to Spring Security, nothing is truly as simple as it seems, right? So let's look at the content. So we have filters in Spring. We have BCrypt, JWT, and SMTP. All right. Filters in Spring. So right before your request, the request actually hits your controller, it goes through these kind of filters that you can implement. All right. So Spring Boot itself has an embedded server, Tomcat, Apache Tomcat. Maybe you might have worked with it for some of your modules, second year modules. What is that called? Client server architecture. Yes. Yeah. Yes. So basically, the request comes into, let's call this container, servlet container, and this request actually gets assigned a thread by the Tomcat itself. All right. So then after that, it goes through all of these filters, and finally it hits your servlet, which I will get to. So what I'm saying is that these requests that come in, these can actually be stopped somewhere, like say here or there, before it actually reaches your controller, which is right after the servlet. So this is kind of the foundation of what Spring Security is. You kind of catch that request right before it even hits your controller, right? So it's my so let me maybe quickly show you what it is that I am talking about. So let me get into my IDE. So let me get into my config. All right, so we have this line of code here from line number 42 to 57. And if you were to have a look at that, so this isn't necessarily any kind of filter logic per se. So it's basically like, let's think of it as the main security rules, right? So it's a bean, of course. So if you were to have a look at what is actually going on here, you have, first of all, you have this builder, right? The builder which builds these security rules. So first of all, we are disabling CSRF, because here we are not making it stateful, we are making it stateless. And remember how I told you that your backend generates these session cookies? So because we are going with stateless and working with JWTs, it means that we should stop the generation of session cookies, right? Simple. So the first thing that we are doing is we are kind of we are kind of firing the bouncer who checks for these session cookies, because when you send a session cookie, it has to be checked, right? So the first line of code does exactly that. Yeah, so basically you're firing the bouncer, think about it, right? And then you have the authorized HTTP request. So there I have given certain endpoints. So what that does is basically the endpoints that you can see here, /all, /login, /register, /verify, these are endpoints that can be accessed without needing any kind of authentication, right? Because just think, why would you need to be authenticated if you were to just go to the login page, right? And then after that we have session management. So let me quickly show you what that is all about. Yeah, so in session management, which is line number 54, see, we are making it stateless, right? So what we are doing in that line is, what we are doing in that method rather is, we are firing the issuing of these session cookies, because we're working with stateless. And then after that we have another method which I will get to when we are working with JWTs. So yeah, just to kind of give you an idea of what the flow is per se and how these filters come into action, this is what I just demonstrated. And by the way, now coming into the servlet. So remember I told you that the request actually travels all this way, right? But actually even right before it hits your controller, it hits your servlet first. So if you were to think of your controller as, say, maybe a traffic cop, the servlet is like the main traffic cop, right? Because that the servlet itself is what handles the configurations for your controller, right? So this is just to give you a very high level architecture of how the process actually flows, all right? And then we have BCrypt. So let me maybe ask you a question. So let's say you have built an authentication system. You are taking in user data. So question arises: do you how would you store? So let's say the user the user signs up with a username and a password. Now you have to store it somewhere, right? So you have your database. So question arises: how do you store this password? Do you store the password in a plain string, or do you maybe do something else? How many of you think it should be stored in a plain string? Yes, that's right. So your user's password has to be hashed, right? Otherwise, you could do a simple query and get everyone's passwords, right, from your database. So these are security practices. And please, when you're making any kind of system, make sure to hash your users' passwords. All right. So one way in which you can hash these users' passwords is by using BCrypt. All right. So in BCrypt, you are able to specify a kind of algorithm, and it will and you can specify the number of rounds through which the user's password will be hashed. All right. Yes. So for example, if you were to go with something like 12, if you were to maybe hash it 12 times, so you have to take that password and hash it 12 times over and over and over again. All right. So now there's another kind of logical question. I mean, you might ask me, okay, James, what if you have, say, two different users, but both of their passwords are the same and it's hashed? So wouldn't both of those be hashed the same way, no matter even if you specify the rounds? That might be a bit of a problem, wouldn't it? But BCrypt actually has something called a salt. It's something that it generates to make sure that two users with the same password get different database hashes. All right. So believe me, there's a lot more going on with BCrypt. I'm just giving you a very condensed explanation. So yeah, let's have a look at BCrypt. Yeah. So let's go with the registration flow basically. So I'll just show you what my programming is like. Then after that, we'll fire a request from Postman so you can see what it's like. And let's have a look at the database as well alongside that. So let's go into my hashing and controller service. So that's somewhere here. Let's authentication flow. Yeah. So let's have a look at how it is that this password is hashed. So you have my DTO in my method here, create user. So if I were to go into save user, so in my user service class, we are initializing this bcrypt password encoder and we are specifying the number of rounds through which the password has to be hashed, right? So first of all, we are initializing the user entity, we are setting the username, we are setting the password, but we are not just setting the password, otherwise it would be just the string, right? So here you pass in this object of bcrypt password encoder and we call a method called encode, and from there we are hashing the password. So that is what that is. So maybe I could show you that. Oops, I'm not running my Spring, of course. That happens, right? You send the request and to say you're not even running your application. Yeah, so let's give that a quick second. Yeah, so we are running. So can I have someone's email if you don't mind? Okay, so that's that, and let me send this right. Don't worry about this OTP phase for now. I'll get to that soon. Zero 56229. Okay, so maybe I could show you how it is that this hashing is going on. Yeah, so if you have a look at this, can't seem to zoom that in very much, but if you have a look at the second row, so here we have Avanish's username, and as you can see, his password has been hashed. All right, so that's just to show you what that flow is like, right? And then let's have a look at how it is that let's say now you're going to log in. All right, so when you're going to log in, of course you will be sending the user will be sending just a string, right? So it's up to you to hash that string, quickly check it with what's in the database, and make sure that this is the actual user. So okay, let's maybe let's try logging in. Okay. Yes. So don't worry about this token for now. So see what we are doing here is, so I entered that password, right? This rather weak password, Avanish 2004. And now what your backend does is it runs through this, takes this password, does the hashing, all right, and it checks with the database to see if it matches, all right. So in my security config class, which is our configuration class, so here I have implemented provider.setPasswordEncode. So basically the request comes in, it's stopped, and the mechanism that I said right now where our passwords are checked is done here. All right, so that is pretty much what that is. And yeah, let me continue. All right, so now let's have a quick look at what this JWTs are, JSON Web Tokens. So like I mentioned earlier, here we are working with stateless authentication. So JWTs, like I mentioned earlier, the tokens themselves prove their validity, right? JWTs actually have a structure. Okay, so first you have this header, and then you have a payload, and then you have your signature, right? So let's have a look at what this structure is like. So you have this, the header, right, and there you can see an algorithm there, which will be very important later on, and then we have the payload as well as the signature. All right, so what happens is once you are authenticated, in the backend, your server will generate a kind of signature. All right, it uses this algorithm and it generates a signature with which your JWT is issued. All right, so, and as you can see in this payload, you have the subject, you have the name, admin, issued at time. There should be another key here called exp, expired time. So that is kind of what the structure of JWT actually is. All right, so it makes sense, right? The token itself proves its validity. Let's see, you can see the name here, you can see the user role, right, compared to stateful earlier, right? So that's that's a major difference between stateful and stateless, right? And yes, so now question arises, let's say you are logging into your backend, you are going to a certain endpoint which requires to be authenticated, and you have this JWT token with you. So you might be wondering, okay, how does the server actually verify the JWT that it receives, right? So what it does is, when the server receives this JWT, it will kind of it will break it down, right? So it will take this it will take this algorithm, it will take this payload as well, and it will do a kind of let's call it encoding. It will do a kind of encoding, and then it will generate a signature. The server itself will generate a signature, and remember the JWT that you sent, so it will compare both of the signatures, and if that matches, you are authenticated. So I know I kind of skipped through JWTs a lot here, and just for the purposes of this demonstration, I'm trying to keep it condensed, but please, I advise you to follow up on these concepts if you are to build your own authentication, or maybe just authentication for that matter. So yes, another demo by James. Let's have a look at how it is that this token is generated. All right. So if I were to go into my controller here, so I will show you how it is that these signatures are generated. So let me quickly go into my IDE. Yeah. So once the user is authenticated, once they are verified, we return them a JWT, right? So let's have a look at how it is that it is generated. So yes, we have the claims, we have the username, and maybe I'll just quickly show you how it is that this secret key is generated. So we generate a secret key using an algorithm, and we use that to kind of set our signature with it. All right. So that is what that is, and yeah, so that's kind of what this entire service does, right? So as you can see here, we are setting the issued at time, which is the moment that the token is issued, and then we are setting the expired time as well. So here, see here, you are able to kind of set what you can set at what time the token will be valid for exactly. So if you wanted the token to expire, say 5 minutes from now, right? So this method allows you to do that. So just to show you how it is that the signature is generated, and yeah, yes, so that is pretty much how the JWT is issued. Yeah, so maybe let's log in as Avanish again, and I'll take you through how it is the JWT is actually verified. Okay, so JWT login, and so see, you log in and you get your JWT, right? So now let's maybe have a look at how it is that this is kind of compared. So do you remember those filters that I spoke about earlier? So you can actually implement your own kind of filter known as your JWT filter. So what this filter will do is it will extract the token from the header and such. Maybe I'll show you just one more thing. Quickly copy this. Yeah. So now we are going to access this endpoint hi using the token that was just issued to us by the server. All right. So let's send that. Yes. So here the header is authorization, and the authorization type is bearer token. So here we are attaching the JWT and we are sending it, right? So I'll just take you through how it is that this actually works out. Yeah, let's make it quite fast. Yeah, so remember this method that I spoke about earlier? So here you have to actually add your filter, right? Let's go into JWT filter. Yes, so if you kind of go through this line of code here, so basically you get this, you are able to extract the authorization header, and you are able to extract the token as well, right? So that is what this filter does, right? So you send this particular JWT, and your filter, what it will do is it will kind of break down your JWT. It will get the header authorization, and then it will extract the token, right? See this one right here, token auth header dot substring 7. So it will extract that token, and if you can see, it actually does all of the business logic then and there, right? So here we have, you check if the username is not null and whether if the thread has been authenticated before. So once all of that is completed, you of course need to tell Spring that, okay, look here, this user has actually been authenticated. So for that, you assign your security context holder, and you tell your security context holder, okay, this request is authenticated, this user is authenticated, and then it will move on, right? So yeah, that is pretty much what there is for JWT. And I know I kind of made this maybe a bit too much condensed, because there is, believe me, there is actually a lot going on here. So because I mean, Spring Security itself, like I mentioned earlier, it's pretty much a black box, right? Even in tutorials, they will say, okay, look here, do this, implement that filter, do this service class. So it can get very confusing as to why it is that you're doing these things, right? So yeah, that is what JWT is all about, and there's a lot more going on. So I would highly suggest, if you're going to build your own authentication, to perhaps read some documentation or follow certain tutorials. Right. SMTP, simple mail transfer protocol. So maybe you all saw when for the BCrypt demonstration, Avanish got an OTP, right? Avanish got an OTP, and we were able to get him in and log in with his weak password. So SMTP, actually, it's actually just maybe let's think of it as a standard, right? It's what Gmail uses to make sure that all of their, let's say, the emails are all standardized, right? And SMTP is also what we use to send emails from our application to the users, the recipients inbox. All right. So yeah, so as the slide says, it acts as a digital post office, right? Your application sends a message to this digital post office, your SMTP server, and there onwards, it's up to the SMTP server to send that email to the relevant recipient. Right? Maybe I'll just quickly show you what the flow is like. So here, right before I show you the flow, here because we have an application running Spring Boot, we use SMTP to take care of that for us. All right. So yeah, so we have SMTP and we have the message that we generate in Spring Boot itself. And maybe if you could have a look at this flow here, right? See, you have the message generated within your Spring Boot app itself, which we will see very soon. And then you have the actual message itself, which is forwarded to the SMTP server. And from there onwards, it's sent to the recipient's inbox, right? So can you see here? Here, SMTP server is like a digital post office, right? Because you are sending the message from your app to the server, and the server sends it to the recipient's inbox, right? Anyone work with SMTPs? That's right. All right. Yeah. So let's have a look at how it is that we can implement SMTP in Java. So you actually have two kinds of mail senders in Java. So you have simple mail message and my message helper. Both of these are classes, by the way. So in simple mail message, if that's mainly there if you want to say send simple emails, right? Maybe you don't have any attachments, maybe it's just some text, whatever. So simple mail message is quite enough for that, and that's what we will be using. But otherwise, if you have to say send some kind of email with say some attachments, some images, whatever, you would go for my message helper. But here we are going with simple mail message. All right. So maybe let's have a look at the code just to show you how it is I've done this. So you should know that, see, if you were to have a look at all of these, if I were to expand all of these packages for you, see, there is so much of files and so much of configurations to do just to get some authorization going on, right? This is a bit of an important point. Maybe take a quick screenshot of it right now. So let me get into my controller class. Yeah. So right. So after password hashing, which we saw in BCrypt, we are generating an OTP, right? Because of course you need email verification, right? Otherwise, how would you know that this is an actual person? So let's go and generate OTP. All right. So I think maybe you might have worked with Java util.random maybe during tutorials. Yeah, for SD2. So now the thing is with Java util random, when it comes to actual random number generation, from what I have learned, it has to take a kind of seed, right? So most of the time, this seed can be things like, say, your system's current time. All right. So now just think, if you were to use, say, util.random and generate a string of integers, whatever, the seed for that might be your system's time. And this is actually a security vulnerability. What if so? Because if you are using your system's time as the seed, it can be reverse engineered, right? The OTP can actually be guessed, and that's why util random is not necessarily util random isn't really used when it comes to these kinds of manual authentication, right? Right. So what we do is we go with a class in Java known as secure random. All right. So remember I told you about that seed and how if you have to generate random things, it has to use a kind of seed. So what this secure random does is it will look at temperature fluctuations in your PC, because PC's temperature goes up, goes down, goes up, goes down. So it will kind of take a quick reading, maybe within the span of a few milliseconds or microseconds, I don't know, whatever, and it will generate, and that's noise, that's entropy, right? So it will generate integers based on that fluctuation. There's a lot more going on here. I'm just making things simple. So that is, so from that it generates, you are able to generate random integers, right? And by the way, you should know that secure random is it's kind of a heavy process to run. So it's best to have it run while Spring Boot is being initialized, right? You wouldn't want this to initialize every time you have to send an OTP, right? Because it's quite heavy. Because just think, I mean, just to read those temperature fluctuations, it it demands some memory, right? If you think about it. So that is what secure random is. And yeah, so from this code we are just stream APIs, by the way. So we are generating a string of integers, right? So 6 integers between 0 and 10. Yes. All right. So that is what that is. Yeah. So then after that, I think I have a few more points. Yes. So let me quickly show you this one. Yeah. So remember about SMTP. So you actually have to do some kind of configurations for it, right? So so if you have a look at the code from 12 to 16, so these are all configurations. So you have to define who your SMTP host is. You have to define the port, username, and your password, right? So to actually get the username and password, to get the password rather, the username is just your email. The password is quite simple. You just have to go to app passwords in Google, and you are able to generate one for this, right? And yeah, and there are a few more keys here which is required for SMTP to work. So this is just to show you what application or properties is like. And what else? Yeah, let me quickly show you the verification token class. Go back to my controller. Yeah. So you see, after you generate this OTP, you take that code and you initialize the entity with it, right? So let's go into my verification token. So yeah, so this verification token, maybe let's have a quick look at what it is. So one user can have only one verification token, right? You can't have many, right? So here it's a one-to-one relationship, okay? And you see, when this verification token, when it takes in the OTP string as well as the user object, upon initialization, you are setting an expiry time as well, right? So that is what that is. So now let's look at how it is that the email is being sent. Yeah. So just think about it this way. Now let's say you are having your user sign up, and it has to be verified as well, right? So having all of that on the main thread doesn't really make a lot of sense, right? Because they probably have to wait. They'd probably be on the main thread for about 15 seconds, and your entire application is, well, what I'm saying is it's a waste of resources, right? This is where asynchronous processing comes into play, right? So you allow the generation of this mail to be done asynchronously, all right? Yeah, so simple mail message, that's the class. So we have set the You have set who it's from, subject, recipient, OTP, OTPs, then you send it, right? Yes. So can you see there is just so much actually going on which we have to implement when it comes to actual manual authentication? Yeah, so maybe we can do another one. Maybe I guess we could do that. Can I have someone's email? Maybe someone who is logged into your Gmail account on your phone. Anyone? We did Avanish. Let's do someone else. Maybe. Yeah. So once we go with register, Tinal should get an OTP. All right. So yeah. So you see how it's asynchronous here. You are not having the email sending on your main thread. You made it asynchronous, right? That's what that annotation asynchronous actually does, right? So you wait, let me quickly copy the thing. So if I were to go to verify, and if I were to enter Tinal's username, and if I could get his OTP 565795, right? Yes, that's how SMTP comes into play. All right. So going through this, I think most of you are quite. I know it feels quite boring, right? When you have to build authentication from scratch, because just think about it. You have to take care of JWTs. It's up to you to sign those signatures. Sorry, it's up to you to implement those signatures. The server does the signing. So, and then you have the SMTP part where you have to use whatever simple mail message, my message helper, whatever it is, and it's up to you to send the emails to your users, right? And it's up to you to hash their passwords, right? See, the thing is, these things it takes up a lot of configurations, right? And it's so many lines of code, and I know it gives you so much of manual control over it. For example, you could set you could set the expiration time for your JWTs and such. You can implement your own signing algorithm. But the thing is, see, you also get that burden of security liability as well, right? Remember those secret keys that I showed you when it comes to signing those JWTs? Now, what if, let's say, you hard coded one? What if that got leaked? So that's a vulnerability right there, isn't it? Because now hackers are able to reverse engineer your signature and they can forge JWTs. And what happens next? Your application, they might send maybe malicious requests or such. So that's why when you are doing manual authentication configurations, you are taking on that security liability risk. All right. So now this is where the star of today's show comes in, AWS Cognito. So you saw just how much of configuration that was, right? You saw we went through all of those classes, all of those methods, those builder methods and such. So you saw just how tedious that was, right? Now coming into managed authentication, right? Where you offload some of that to Cognito. So what are these things that we are offloading? We'll see after a 5-minute break. Right, so let's get back to our target. So, like I mentioned, the star of today's show, AWS Cognito. So, let me quickly change my branches and let me show you something. Let me go to my GitHub desktop. Okay, let's go back to main. So before I switch, just have a look at how much of code, how much of configuration we had to make here, right? How many files there? See, even just in the service package, you have 1, 2, 3, 4, 5, 6 repository, entity, controller, config, right? So now have a look at this. Oh my gosh, what happened to all of the code? Let's give Maven a second to resolve. Yes. So what happened to all of those packages? What happened to our repositories? What happened to our services? What happened to all of those configurations that we made? Now you have just your controller and your configuration class. What happened to all of that boring stuff I put you through, right? So all of that got cut down, right? Yes, exactly. So let me quickly show you, before I actually get into Cognito, maybe let's talk about symmetric and asymmetric cryptography, just to kind of remember these concepts. Yeah. So what we did, our manual authentication, that was entirely symmetric cryptography, right? The one key both signed and verified through signatures, right? So yes, so like I mentioned, if this key is leaked, that causes a problem, because, well, it's a massive security vulnerability, right? So enter asymmetric cryptography, right? So here, our identity provider holds the private key. Our identity provider is the one who signs the JWTs, right? And then our identity provider also holds the public keys as well, which we access through Spring Boot. I'll get to it, don't worry. So what? So basically, the same key is not both signing and verifying that signature. All right, that's what asymmetric is all about. And also, as your app scales, maybe you have microservices coming in, maybe you have a lot more of the same services running in different, let's say, availability zones, and you have really scaled it. So in that case, all you need is, and your microservices can actually access these public keys, and these public keys can be used in that way. All right. So let's move on. And yes, these are the public keys that I was talking about. JWKS, JSON Web Key Set. So basically, there is this URL. It's a public URL, right? And it holds all of these. It holds an array of keys, right? So your verifier downloads these keys, and it checks against the private keys. It checks against the signature that it receives. All right, I'll get to it. Don't worry. So let's finally get into the star of the show today, which is AWS Cognito. So maybe a bit of a quick story before I start. So when I was actually preparing for the AWS certification, AWS Cloud Practitioner, they covered a lot of AWS services. Actually, you have about, I think, more than 200, but in that certification we covered around 40. All right, and there was this one service which I felt was kind of underappreciated because it wasn't spoken about all that much. So I thought, why not make a project with it? And here I am before you today. So AWS Cognito is actually a service from AWS, so that lets you add user sign up, sign in, access control, and brokered AWS service access to your web and mobile application within minutes. All right. So basically, if this is your web application, this is what you are using for your authentication. You send the username and your password to Cognito. Cognito stores it. Cognito takes care of the password hashing. Cognito takes care of the sending of the emails. And so, and it takes care of all of those things that we set up manually, right? So, but that's actually one part of Cognito. So you might be asking, what are the other parts of Cognito? So Cognito, you actually have, let's call it as you have two main parts of Cognito, let's put it that way. So you have identity pool and you have user pools. So I'll just quickly start with identity pool. So in identity pool, what you're doing is you are allowing your front end, you are giving access to your front end to access AWS resources, your AWS resources, right? How many of you have maybe lightly worked with AWS even? Yeah, so maybe you are familiar with S3. Yeah, S3 is a storage utility service. All right. So you could actually have your front end upload a file directly to S3 without having to go through a backend, basically. So that is what identity pool does, and we won't really be working with it, but it's one of those services which are a part of AWS Cognito. So now comes into user pools, which we will be working with today. All right. So like I mentioned earlier, it manages the users' passwords, even MFA. If you want to implement MFA for your users, you can use Cognito. It's compliant with the OAuth 2 standards, and it takes care of access IDs, refresh tokens, and see, it takes care of all of that manual configuration that we had to do. All right. So let me move on. Yes. So maybe I'll show you that diagram first. I have that. Yeah. So do you remember back in the OAuth diagram that I showed you, the third party delegation, there you are allowing another service to access data from you, from a provider. Airbnb is trying to access Google, and Google asks permission from you if this data can be accessed, right? So here things kind of change a little bit, all right? Because now, if I were to tell you about the app, actually, it will be in React. So from React itself, you are making your users and you are sending it straight to Cognito, right? There is no backend in the middle, all right? So if I were to come back to the OAuth first party architecture, so React is actually React has permission here, right? React is a public app client, right? So it gets permission to access data about you without having to necessarily ask you for permission, right? That's pretty much what the public app client is. So React is the public client, right? Yes. So, and then if we were to talk about the offloaded liability, see, now let's assume that there is some kind of vulnerability in the standards that we spoke about. Let's say OAuth, maybe there is some kind of security vulnerability, and let's say in OIDC, whatever it is. See, if there were a vulnerability like that and you did manual authentication, so you would have to constantly follow up, right? You would have to check on news. Okay, there is this vulnerability. I'll have to fix it, right? Versus offloading it entirely to AWS, right? Because it's now AWS's burden to bear. It's up to them to fix these vulnerabilities, not us, right? So that is let's say a difference between managed authentication and manual authentication. So yes, so I'll just maybe give you a quick idea on this data flow. So from our front end, we are sending a username and a password. So Cognito will then verify and issue a JWT, right? So see, even this JWT generation, we are not making any code for it, right? Cognito takes care of it for us. We get it. And now if you want to access, say, a certain protected URL, you send this JWT to your backend, and now your backend, remember it's asymmetric, right? So your backend has to now download those public keys and it has to verify, all right, asymmetric encryption. And then once it's verified, access is granted. So I know I explained this data flow, but it would be a lot better if I could maybe just show that to you. Maybe I'll just show you what this user pool is like in AWS Cognito. So yeah, let's have a look at that. So let's have a look at how we can create one of these user pools. But just before that, we'll have to kind of follow AWS's rules of basically we have to make an IAM user first and attach some policies, so add that user to a certain group before you are actually able to go ahead and create your user pool. So let's create a quick IAM user. So over here, if I were to give it a name, let's say test Cognito user order, something like that. Okay. And I don't need to give access to the console. No, I'll just leave this fine. And then right now you can select the password. So I'll go with auto-generated password. So let me click this. So to actually give this user some permission to be able to create the Cognito user pool, for now we can go with this policy called Cognito power user. So for things where you're sending simple emails, Cognito power user works just as well. But later on, if your app scales and if you have to use something like, say, SES or SNS, you would have to add more policies to your user accordingly. So let me create this user. One more thing to clarify, Cognito power user also gives access to the user that we are about to create, the ability to create these user pools, right? And basic CRUD operations when it comes to the user pool, right? So yeah, I'll let myself continue. All right, so we have created the Cognito user, and so let's log in and let's get to work on actually let's get to work on actually creating one of these user pools. All right, so I have now come into the console. So I have logged in with that specific credentials. So first thing we should do, let's quickly change our region. So we are going to the nearest availability zone to us, which is AP South 1, Mumbai. So wait until that refreshes. And all right, let me go to Cognito. All right. So I have actually created the user pool before. I mean, for your demo, I will be using this one, but just for purposes of learning, I will be creating a new user pool. So the first thing we have to do is let's click on create user pool, and after that, here we have a couple of options. So if you're working with the single page application, let's say Angular or React, you can select the SPA option, or depending on your other use cases, you can select accordingly. Here, since we will be primarily working with React, we can use SPA. So let me give this a name. Let's call this demo user pool. And now comes to the place where you have to configure your options. So what happens here is, if you were to look at the options for sign-in identifiers, basically it means by using which method will your users actually log in. So now here, since our users will be logging in with, let's say, email, you can select email. Otherwise, if you are having your users log in with, say, phone number or username, you can select that accordingly. And then after that, we have this option for self-registration. So we will have to enable self-registration. Otherwise, if your user tries to sign up or log into your app, it's going to return an error message. So then afterwards, we have the required attributes for sign up. So the thing is, although in your front end you might have some kind of authentication to make sure that the email which the user provides is valid, it's best to also kind of configure it at the database level, where you make sure that the email definitely is valid. Because just think about it, maybe some kind of person might completely bypass your front end. They might open a tool like, say, Postman or something, and they might send the email to the particular endpoint, or rather they might not send an email to that particular endpoint, and then you are going to be in trouble, because essentially you would have a user with no email, which kind of defeats your integrity, right? So let me select. So here, since we're going with email, let's select email, right? That's fine. And if you also want to redirect the user right after login to, say, another certain page, you could add that here. But here, since we are building this custom, since we are using React, and we might use some kind of state to redirect users to another page right after the sign up has been completed, we can just leave this as it is for now. So let me create this user directory. Alright, so I said that we'll be building our own kind of front end and UI. But the thing is, AWS actually, they kind of give us their own hosted UI. So we can safely ignore that for now, because we will be building our own front end. So quickly go to the overview. Yes. So here we have certain options which I think it's best if you could configure this right away when you're making your user pool. Because see, here you have certain options for refresh token expiration, access token expiration, ID token. So these things are things which it's best to configure right as soon as you have made your user pool. So if you were to take something like refresh token expiration as an example, basically it means that your users won't have to continuously generate their password over and over again while they are logged in. And then afterwards you have your access token expiration, which is JWKS, of course. It defines how long your access token will be valid for, or rather how long that session will be valid for, until, of course, you send a kind of refresh token. And then there is the ID token expiration, which is actually a front-end kind of thing. It's mainly for your front end and AWS to connect, so that AWS kind of knows who the current user is logged in exactly, so that it can kind of display the users. Okay. So of course there are a lot more options, but regarding the most important ones for now, that's pretty much what that is. All right, so thank you for that, James. So we saw how we created that user pool. So now when it comes to actually building our application, there are certain secrets which we will need to implement. So first one being the user pool ID and the app client ID. So remember I told you that React was the public app client. So it is assigned an ID as well, and this is something which you will need to include in your ENV. And then after that you have your user pool ID. We made that user pool, remember, and that has a certain ID to it, and with that you get a certain URL as well, which you would have to attach. So your user pool ID, it contains details of your root account and the user pool identifier, and this is how Cognito actually, this is how AWS verifies your account as well, to make sure that this is the actual, well, user trying to communicate with the user pool, right? So yeah, let's have a look at the front end. But right before that, so I know Cognito is a service, but to actually implement Cognito, to actually maybe use, let's put it that way, to use the SDK of to use Cognito, you have to use AWS Amplify, right? So Amplify gives you like an SDK of sorts, which works with various frameworks. So for this case, we'll be going with React JavaScript. And so we can use Amplify to basically build out the methods and configurations that we need to access AWS Cognito. So yes, right. So you guys have worked with React, so kind of familiar ground. So let me get to my right. Okay. So before I go into the code, I'll just tell you what my URLs are. So we have the root, we have login, hi, and 404 not found. All right. So maybe I'll take you through the sign up form first. I think I can start there. Yes. So let's start with that. All right. So if you have worked with forms in React, I think you know that setting state for your fields is, it kind of what do you say? It can be a problem for your browser memory. So because of that, I actually found this framework called React Hook Forms, and yes, and so that doesn't use any kind of state basically. And then after that, we also have to make sure that the email is actually valid, and for that you have to define a schema, right? You have to say, look here, you can give some regex, and you can specify certain stuff that has to be in this credentials, right? So for that I have used a package called Zod, right? So let me quickly just tell you what's going on. So you see, in React, I like to think of it as a master switchboard. All right, some switch gets turned on, something happens, another switch gets turned on, right? So that entire kind of idea is conveyed over here. All right. So yeah, let's just, maybe I'll not show you everything. I'll just show you what you need to know. So yes, so here we are sending the email and the password, and then we get a variable back. Next step. So await sign up is a method from Amplify itself. Yes, sign up is a method from Amplify itself. So you send your email, you send your password, and once the next step has been confirmed, you now go into the OTP phase, right? So that's a state right there. So there's a state which checks if you're in the OTP phase or not, right? So now assume that your user has gone into the confirm sign up page, confirm sign up phase, and now you render the input OTP form component, right? So if is OTP phase is true, you render a certain component, otherwise nothing, right? So let's go into input OTP form. Let's make it quite quick. So again, schemas, and then you have confirm sign up, where you give the email, and remember, Cognito takes care of the email sending for us, right? So you quickly enter the OTP here as well, and it gives you a variable is sign up complete. So if that is true, you can navigate into the login component, which is this one. So after the user gets verified, we are forcing them to log in as well. All right. So, and after they log in, we use another method from Amplify called sign in, and once that's correct, once that's done, we go to the high endpoint, which is this one. All right. So now we are sending this token to our backend. You remember, right? The backend has the job of taking the JWT and checking it against the public keys, right? So we are using TanStack query. I hope no one is using Axios these days after that vulnerability. You're smiling, so that means you have used Axios. Yes. So please be careful. Don't use Axios. There's a massive vulnerability with that. So TanStack query is used for, of course, not just our API calls, but it takes care of a lot more things like caching, session management, and such. So TanStack query is quite superior. So so to our backend, we have this URL. Can I get that URL? Yes. So we fire the response with the headers, right? So remember, Cognito now gives you that access token. It gives you the JWT. So if you were to access your backend, you would have to attach that token as a header, right? So that is what we are doing over here. So we are making a GET request to that endpoint with the authorization header, right? Maybe I'll show, yeah, this one over here. So remember this token variable, you are able to get it from the Amplify methods. So you extract the token and you add it, all right? And then you send it to your backend, and then you have a look at what the response is. So maybe we can test that out. Is there anything else I'll have to? Yeah, so let's have a look at my backend configuration. So you all remember that pre-flight request that I spoke about? So here, since we are sending the header from our front end, which is authorization header, so in our backend, we will need to specify that, right? So that is pretty much what we are doing with this bean. Yes, so you are setting the allowed origins, the methods as well. So here we are making a GET request to an endpoint. And yes, that is what that bean does. And maybe I could show you another thing. Yes, so remember that the authorization header, that token, earlier we had the job to extract that the JWT from the header, right? So here Cognito does it for us from this .OAuth to resource server method, right? And I think there was another thing which I have to show you. Yes, I have to show you the RSA engine. So remember I told you about how the backend has to now download the keys, right? It has to download all of those public keys. So the endpoint, or rather the key that makes that possible, is springsecurity.auth2 resource server.jwt issue URI, right? So when you add this and when you give your issue URI, which I can't show you obviously, when you use that URI, it will basically it will download this relevant public keys, right? So regarding how these keys are cached within Spring itself, there's quite an interesting mechanism behind that. So it still feels a little black box, doesn't it? Because see, even here Spring is taking care of so many things for us. It's downloading these keys and it's caching it as well, right? So yeah, so maybe let's sign someone up. Maybe who would like to go next? Maybe I'll run this first. CD front end. I have to make sure my backend is running, otherwise just stop this for now. I think I'm on the earlier one. Yeah, so I have to make sure that my backend is running, otherwise we won't be able to verify. Yes. I'm running quite a lot of applications in parallel, so Spring Boot is taking some time to initialize. So let's keep that a quick second. Okay, so that's fine. So let me go into this and npm run dev. Right, so let's maybe do a sign up, and if I could get someone's email. How about the gentleman at the back? So this is the sign up phase, all right? So, oh, I have to contain one uppercase letter, right? So, and I think I need one special character as well. Yeah, that's fine. So see, that was my form validation package coming in, right? It's called Zod, by the way. I have included links for these various packages and things that I spoke about. It's there at the end of the slides, all right? So can the gentleman at the back kindly tell me what the OTP string is? Yes. Yes. 60. Right. Okay, and we are taken back into the login page. And now if I were to click on submit, it should take me to the high endpoint. And yes. So the gentleman at the back is now successfully authenticated. And if you have a look at this, if you have a look at this UUID, so this is something which AWS generated, all right? and this is something which we have accessed. All right. So do you see just how simple managed authentication made things for us? Right. All you have to do was just configure your front end a little bit, and now your backend just has to verify the JWT. Right. So compared to building these authentication systems by ourselves, wouldn't you agree that managed authentication does take some you know, configuration of our heads, right? Because now here, did I configure any kind of email server? Here, did I do any kind of password hashing, right? Did I work extensively with JWT? Not at all, right? So Cognito took care of all of that for us, right? And there are links to the documentation on Cognito if you are interested in using it for your future projects. So this goes on just to show you just how easy managed authentication actually is, right? And yes, so the gentleman at the back is successfully authenticated and all is right with the world. So, all right. Thank you so much. And I just wanted to show you how simple it is to just offload that risk of security and manual authentication to a third party provider, right? Okay, thank you so much.